All right, here's our video today. Archaea versus bacteria. And in the background there, you see that looks like some alien world somewhere, perhaps on Titan. Very strange world. Well, that's a hot spring. And the thing about archaea is they can survive and thrive in the most extreme environments on Earth. They can live in temperatures above 176 degrees Fahrenheit. So we'll talk about archaea, even though many people don't talk about them. They lump them together with bacteria. In fact, a long time ago, and still used today in some textbooks, is they were lumped in as the Monera kingdom. And you might see them on tests still. But that Monera kingdom, the five kingdom system, was replaced by the three domain system because scientists now know that archaea are separate from bacteria. In fact, archaea may be more closely related to us than they are to bacteria. So let's look at that. So here's the three domain system. We have the bacteria, as you can see, the archaea, and we have what we are, eukaryotes. The eukarya system, we're eukaryotic, we have a nucleus. Bacteria and archaea, they do not have a nucleus. And good luck trying to tell them apart. So they're both single-celled, they don't have a nucleus, they're prokaryotic, they're microorganisms with asexual growth, similar size, but there is a difference, and we'll look at those differences. For one, and I'll write this down, let's get our pen going. Let's use red. And only bacteria have peptidoglycin. I'll write it down for you. Say it a few times, you'll get it too. Do it slow. Peptidoglycin. And I'm separating the words so you can look at how it's pronounced. So again, peptidoglycin is actually combined in one word here. It surrounds the cell wall of bacteria and protects bacteria. But archaea does not have it. In fact, we don't have it. No eukaryotes have it. So that's one difference between them. And here's another difference. So in our DNA, in any DNA in eukaryotes, we have negative DNA wrapped around positive histones. So we'll get the marker going here. So DNA has a negative charge, and the histones, these things have a positive charge, and as you know, unlike charges combine, they attract each other, and they wrap around each other. And so archaea have this. They have positive histones for packaging DNA. Bacteria does not. So our DNA and the DNA of archaea are clustered. That's one big thing that they have that our bacteria doesn't. And when we're talking about DNA, when we want to talk about protein synthesis and transcription, when we're using, let's make a, there it is here, you can see it over here, you see the DNA, but I'll make the double helix right over here. So when we have this, we have mRNA, messenger RNA, that transcribes the genetic code in transcription. And the enzymes used to process, read, and replicate that are similar in archaea and humans. So I'll write that down over here. The enzymes, by the way, the enzymes are RNA polymerase. So the enzymes used to process, replicate, and read the genetic code is similar in archaea and us, all eukaryotic life forms. So from that idea itself, the idea that Archaea have positive histones for packaging DNA, that they have the similar RNA polymerase, these enzymes used to process and read and replicate our genetic code. And, in general, then, their protein synthesis, making proteins, are similar to us than to anything else. So the Archaea are more closely related to us and dogs and T Rex, apples and Aunt Sally, and all eukaryotes, all eukaryotic life forms that have a nucleus. They're more related than they are to bacteria. And one final thing we'll put down is there is no evidence that Archaea is harmful to us. So they're not pathogens. Very important to know they're not pathogens. They do live in our gut. We have a very small amount, about maybe close to 2% can live in our microbiome. But again, they're not pathogens like bacteria could be. Now, bacteria could be very beneficial. We need bacteria in our gut. We have over 30 trillion bacteria inside of us. Some are harmful, as you know. But again, no Archaea is harmful. So let's sum this up. So we know that since we're more closely related to Archaea than bacteria, Archaea should have their own domain. In fact, there is some evidence, and some scientists think that maybe we evolved from Archaea and that there should be only two domains. Right now we have a three-domain system. But again, we know that bacteria and Archaea look alike. You probably wouldn't be able to tell them apart. They are single-celled, no nucleus, obviously microorganisms, with asexual growth, similar size to bacteria. And again, bacteria, if you remember, they have a certain chemical that surrounds their cell wall. It's peptidoglycin, if you remember from the video. But the similarities stop there because Archaea have positive histones that package the DNA wrap around these positive histones. Bacteria does not have that. Our DNA is clustered like Archaea. The enzymes used to process and read our genetic code are very similar in Archaea. And when they make proteins, it's very similar to us. So that's why Archaea have a separate domain. And again, they used to be clustered together in the Monera kingdom, but now, again, domain is the highest form in taxonomy, where kingdom is the second highest. All right, that's our video today.